Hey guys, so this is a bit of a summary video for you on sequences. So I'm just going to rush through it. I'm not going to spend too much time on everything, and hopefully this is just a reminder. Okay, so I've got some series here. What if I want to come up with a rule for them? So the first thing I'm going to do is look and see if there's a common difference, and there is. I can see that everything's going up by 2. So my rule is going to be 2n something or other. So what I'm going to do is just figure out how I get to 5. So 2n, so n is 1 because it's the first term. So then I'm just going to add 3, right? So 2 times 1 plus 3 is 5. Let's just check and see if it works for this one. If this is the fourth term, 2 times 4 is 8 plus 3 is 11. Great, that works well. Same thing here. What's the difference between them? Well, it's always going up by 5. So my rule is going to be 5n something something. How do I get to 4? Well, I just subtract 1 if I'm doing 5 times 1. Then I'll check it for this one up here, the fourth term. 5 times 4 is 20, minus 1 is 19. That one works as well. Now you can have some simple things. Sometimes, let me just grab another colour. Sometimes you might have things just like this. Right, so if I had something like that, what am I doing each time? Well, the rule is every time I go to a new term, it's multiplying by 3. So this is a geometric sequence. These were arithmetic sequences. So what I'm going to do is just say u of n equals 3n, right? 3 times 1. Oh, that is absolutely not true at all. I have written that completely incorrectly. Please ignore me. Gosh, okay, we're just going to pretend that didn't happen and my brain didn't just die. This is actually a recursive thing I'm talking about. Oh my gosh. Okay, let's go back and call this 6 times 3. This is going to be 9 and then 12. And this pen's running out. So the rule would be 3n in that case. So 3 times 1, 3 times 2, 3 times 3, 3 times 4, blah, blah, blah. All right, let's have a look at some finance. So there is a nice little rule that you should have looked at that whether you remember it or not is a thing. So I'm just going to show you the rule that I would use. So what I'm going to do is I'm going to say the amount is the principal. So P is the original amount I start with. And then 1 plus R to the power of T. So R is my rate as a decimal, so my interest rate as a decimal, and T is the time in years. It's the amount that I would have. So let's say with this information, I started with 680 bucks. I invest it for 7 years at a 6.3% interest rate. So I'm going to say the amount is going to be $680, and then 1 plus R, which is 0.063. You must turn it into a decimal, not a percentage, all to the power of 7. So all I'm going to do is type that into my calculator. 680 times 1.063 to the power of 7, and I have $1,042.90. So that's how much money I would have after 7 years if I did not touch it. Now we can do things backwards. What if things are depreciating? What if they're getting worse over time? So that can happen with, you might buy something like a couch or a car or a computer, whatever you buy, it's going to devalue over time. So I'm going to use the exact same formula, but I'm going to do 1 minus R this time because I'm losing money, right? So again, I start with my principal amount and then I multiply it by 1 minus 0.041 all to the power of T. And I'm just going to type that into my calculator. 2300 minus 0.041. And that is all to the power of 5. So then I have 1,865.61 cents. So that's how much this would be worth if I started with this amount and it depreciated over time for 5 years. Okay, over here, this time we have a geometric sequence. I'm just going to use this to find the first term and the 11th term. So all I'm doing is substituting in n. So the first term is just negative 3 times 2 to the power of n plus 1. Well, that's 1 plus 3, plus 3. So then I have negative 3 times 2 to the power of 4, which is negative 3 times 2, 4, 8, 16. And hopefully you can do that kind of stuff. That will give you negative 48. So that is the first term of this sequence. So then what I'm going to do is the same thing. So negative 3 times 2 to the power of 11 plus 3. So 2 to the power of 14. So negative 3 times 2 to the power of 14. And that's going to get me negative 49,152. You can use a calculator for this stuff, that's fine. Something like this is a bit easier, but something like that is fine for a calculator. So what if I do it backwards now. So this time I'm going to give you some information and ask you to come up with the sequence. So the first thing I'm going to do is say I know that there's a 10, then there's something, so the 4th term, the 5th term, and then 19. So I'm going to have to go up by a consistent amount to get there. So I could try going up by 2s. If I went up by 2, I'd get 12, 14, well, I'm not going high enough. So let's try 3s. I'd get from 13, 16, 19. That sounds better to me. Now I'm going up consistently by 3s because I do know it's an arithmetic sequence. So then all I have to do is work backwards to find the first term. So if this is the 3rd term, the term before it, I'm just going to minus 3 and then minus 3 again. So the first term is 4. The 12th term, I can just keep going up. So if the 6th term, well, first of all, it might just be easier at this point to come up with a rule because you've got enough information, right? So if the first term is 4, the difference between all of them is 3. So my rule is going to be 3n plus 1. That makes sense to me. 3n plus 1. I could test it with this 3n plus 1. 3 times 3 plus 1 is 10. It works. So then I want the 12th term. So 3 times 12 plus 1. 3 times 12 is 36. So it's 37 is my 12th term. Okay, so let's start doing the complicated stuff. This is the crazy table stuff. So what if I now have, I'm gonna find the difference between all these things and figure out whether it's quadratic or cubic. So what's the difference between all these numbers? Difference between, okay, so let's go 1, 3, 5, 7. Difference between all of these, 2, 2, 2. Excellent, I can stop. So this tells me I've done 3 steps. I know it's a quadratic, okay? If I had to do a 4th step, that would make it a cubic. So then what I'm going to do is, remember we used some algebra to do this, so I'm just going to rewrite my sequence up here. And I'm going to rewrite things using algebra. So I'm going to start with A plus B plus C. Then what I'm going to do is I'm going to pretend all these coefficients are 1, right? So all the numbers in front of the letters are 1. Now I'm going to pretend that they're being squared this time. So I have 4a, because remember the first term has got to be squared, then the second term is 2, and I'm not doing anything with my third term. Now I'm going to cube the first one, so I have 9a, and then 3b plus c. Now I'm going to do it to the power of 4, so I should have 16a plus 4b plus c, and to the power of 5, 25a plus 5b plus c. And then I'm going to find the difference between them all, just like I did before. So I should have 3a plus b, then I should have 5a plus b, 7a plus b, and 9a plus b. Now I'm going to find the difference between all of these. 2a, 2a, 2a. Okay, so now what I'm going to do is find the bits that match. So I'm going to say that that equals that. So 2a equals 2, a equals 1. Brilliant. Now I'm going to say that this matches this. So 3a, and I know a is 1, plus b equals 1. So 3 plus b equals 1, so b must equal -2. And then I'm going to go backwards again. I'm going to use this one here and this one up here. So I'm going to say that, where am I? A plus b plus c. So 1 plus -2 plus c equals 4. So this is 1 minus 2, so -1 plus c equals 4, so c equals 5. So if these are my 3 coefficients, right, my pattern is an squared plus bn plus c. This is my rule. So then that means I have a is 1, so n squared, plus bn, which is minus 2n, and c is 5. So that is the rule that determines this sequence. Now we're going to do the exact same thing, but this time we're going to do it with a cubic. This is going to be a cubic one. And unfortunately for us, this one is going to require a lot more space, so I'm going to try and turn my book sideways, and I'm going to have to make sure I don't go out of shot. Let's just double check. Yep, we're okay. All right, so what I'm going to do is use this sequence. Actually, I might start this way. So I'm going to find the difference between all of these numbers. So, oh, actually, I've realized that I wrote the wrong sequence before, didn't I? Okay, we're just going to rewrite this sequence. So 4, 16, 52, 124, and 244. Okay, I wrote some wrong numbers before. All right, let's have a look at the difference between all these things. So we should have 12, 36, 72, and 120. Okay, let's keep going. Find the difference between all of those. 24, 36, 48. We're still not there. 12 and 12. Great. So see how we had one extra step here than we did over here? That tells me this is definitely cubic. So what I'm going to do is now I'm going to turn it sideways. Just double check I'm still in shot. Yep, great. Okay, so maybe I want an actual new page. Oh, I don't think I've got enough space for everything. Okay. Oh, I don't have another page. All right, let's just try and make it work. So I'm going to write my numbers along the top. So I've got 4, 16, 52, 124, and 244. All right, so I'm going to write all these things out as I did before, but I'm going to have to use A, B, C, and D this time. So this is going to be A plus B plus C plus D. Now, this time I'm cubing the first one, squaring the second one, the third one is normal, blah, blah, blah. So instead of what we had before, instead of having 4A, because it was squared, we're going to have 8A because it's cubed. So 8A plus 4B plus 2C plus D. Same thing here, we're going to cube everything. So instead of 3, we're going to have 27A plus 9B plus 3C plus D. Now we're doing everything with a 4, so we should have 64A plus 16B plus 4C plus D. And then we're doing everything with 5. So 125A plus 25B plus 5C plus D. Now I know that's quite small and you might not be able to see it so well, but I've said it out loud, so hopefully we know what we're doing. Then I'm going to find the difference between them all, so the difference between these, just like we did with our numbers. So we should have 7A plus 3B plus C, 19A plus 5B plus C, then 37A plus 7B plus C, and 61A plus 9B plus C. All right, keep going. Let's find the difference again. So 12A plus 2B. Next is 18A plus 2B. Next is 24A plus 2B. All right, keep going. The difference between these two, 6A, 6A. All right, so now we're going to do what we did before and we're going to match up our things. So 6A equals 12, which means A equals 2. And then we're going to go backwards again to this one. So 12A, which is 2, plus 2B is 24. So then 24 plus 2B is 24. So B is going to be 0. Let's try for the next one. So I'm going to use this one and this one. So I have 7A plus 3B plus C equals 12. So then I have 14 plus C equals 12. So C is negative 2. And then we'll go backwards again to this and this. So 2 plus B plus C plus D equals 4. Am I doing that right? What have I just done? So A and B and C and D is 4. Yep, okay, cool. So then we have 2, so 0 plus D equals 4, so D is just 4. Cool. So then I'm going to use my coefficients to write out my rule. So my rule is going to be a n cubed plus bn squared plus cn plus d. That is my rule. So if I put them all together, I will get a is 2, so 2n cubed plus b, so b is 0. That means this term doesn't exist because anything times 0 is 0. Cn, so it's minus 2n plus 4. So that is my rule for my quadratic. Now these two things are definitely the hardest, so you might want to do a bit of practice of those. But apart from that, let me know if you've got more questions. Bye.